All right. So what if we were given an ogive? Ogive is just a fancy name for cumulative frequency graph. All right, cumulative frequency. So remember, this means that we're doing a running total on our table. How many values have we collected? So what's our total number of values? If we look at this, the cumulative frequency, what's the maximum? 100 is the frequency. Okay, so if we were trying to find the 25th percentile, well, first off, that'd be 0.25 times how many values we have, but they made it really easy on this. 0.25 of 100 would just be 25. So I would look on the cumulative frequency and find the 25th value. This is kind of what I'm going for. So on the cumulative frequency, I'm looking for 25. So that would be kind of 30. That would be 25. So I'm going to come across and figure out what mark would go with the frequency of 25. Is that right at 30? Or maybe...
I think that's 30.
You think it's 30? Or maybe 32?
That's what you think.
You think it's 30? Okay. Y'all are just going to go with it? Okay. So the 25th percentile score is 30. Okay. What about the 50th percentile? Where would that be? So we're going to look for where this is 50. Let's see if I can draw a straight line. So mine landed past 40. Yeah, 42, 43, somewhere around there. 43, score of 43 is the 50th percentile. What about the 75th? I'm being lazy. So 75th, we would go here 60 to 80. 70 would be in the middle. 75 would be in the middle of that. And we would just go over. I cannot draw a straight line to save my life. And then come back down. Where do you think that's at? 50? Score 50. Okay. It'd be easier to read, I think, on the computer because you could zoom in better. We can't zoom in on this one. So I should have probably done that with what we were doing yesterday, but we didn't. The last thing we have to do is do what is called standardized scores. So standardized scores are figuring out how many standard deviations away a value is from the mean. So the first thing we need to do is find the mean and standard deviation. Once we know the mean and the standard deviation, we can find the z-score. That's what it's called, is a z-score for the given value. And there's a little formula and equation to find that z-score. Now, what the z-score is telling me, the z-score tells us how many standard deviations away from the mean. So it's telling us how far away from the mean that value is. How many standard deviations away? Is it only one standard deviation away? That means it's really close. 2, 3. If it was 4, it'd be way far away. Thinking about our Like, where the mean is, standard deviation, how far away is it? So the equation to standardize a score to make it into a z-score is this. I'm doing the official one here. So X represents the value, the data value. What is that weird fancy U looking thing? That's the mean. And this weird pregnant 6 looking thing, standard deviation. Hey, we had to find the mean and standard deviation, so it makes sense that we would use the mean and standard deviation in the problem. So what we're going to do is go back to the 15 test scores from earlier in this section, and we're going to find the mean and standard deviation of those scores. So I'm going to flip back. Back. So we use those scores to find our 5-number summary: minimum, Q1, median, Q3, maximum. But now I need to know the mean and standard deviation for those scores. So where would I go on the calculator to have it do that for me? Statistics. And so I would go to statistics, go to my data, 65, 67, 69, 70, 71, 73, 74, 76, 77, 8, 80, 81, 97. And I had other stuff in there and I didn't know it. Okay. Now where am I going to go to find the mean and standard deviation once I have it in there? Stats. Now, when I go to stats, the first things it gives me in the list are my 5-number summary: minimum, Q1, median. It even gives me my range and interquartile range. But after that, it gives me the fancy mean and the fancy standard deviation, and that's what I need for this problem. So I'm going to copy it off my calculator. It's kind of hard to see it on the screen. I got 75.4. Everybody else get the same thing? And the standard deviation, it says, is 7.356. I'm going to go 3 places. So we're going to take 3 scores, 61, 77, and 80, and we are going to standardize them. That means we're going to find a z-score for each of those. We're going to figure out how many standard deviations away from the mean each one is. So for 66, to find the z-score, we're going to take the value minus the mean. So 61 minus 75.4, then divide that by the standard deviation. So 61 minus 75.4 divided by 7.356. Anybody get something? Negative 1.957. So basically negative 1.96. So it's negative. What does that mean about its location from the mean? It'd be to the left. It'd be below. And it's almost a full 2. It's really close to 2. So this is almost 2 standard deviations. I'm going to abbreviate below the mean. That's pretty far away. Let's try 77. So the z-score is that value minus the mean divided by the standard deviation. Now, would you expect this one to be positive or negative? Do you think it's going to be a big number or pretty small? Okay, so let's see. I got 0.218. So it's 0.218 standard deviations above the mean. That's pretty close. It's not even a full one. Last one, 80. So since 80 is bigger than 77, I'd expect this z-score to be higher because it'd be further away from the mean. Let me make sure I have it. You got 0.65? So it is further away from the mean. Now, this is pretty useless here, but what we can do with the z-scores is compare things. Compare things that have a different scale. We're going to do 2 comparisons and then we're done for the day. So the first one we're going to look at is the National Center for Health Statistics study states that the mean height for adult men in the U.S. is 69.4 inches with a standard deviation of 3.1 inches. So I'm going to go ahead and write that down because we're going to need it here in a second. Mean of 69.4. Standard deviation of 3.1. And then it says the mean height for women is 63.8 with a standard deviation of 2.8. And what we're trying to figure out is who is taller relative to their gender, a man 73 inches tall or a woman 68 inches tall. Well, if you just ask the question, who's taller, obviously 73 is bigger than 68. But who's taller relative to the rest of their gender? So you're comparing the men against men and women against women. So we're going to find the z-score for each. So the z-score for that man is 73 inches tall. So I want to know how far away he is from the average height of all men in the U.S. Is it raining? Yeah. It's like either that or somebody's tapping on the window. That'd be very weird. Because we are on the second floor. Okay, now let's see. We got a woman who's 68 inches tall. What's her z-score? In other words, how far above the average is she? Okay, so who is higher than their average more? The woman. So the woman is taller relative to her gender if you're comparing her to other women. Now, another good example of this is college admissions. SAT and ACT scores are on totally different scales. So what if you have one applicant who took the SAT and one applicant that took the ACT? How can you really tell who did better? Well, we use these scores. So SAT and ACT, SAT has a mean of 1,500. So the average score for all students in the US is a 1,500 with a standard deviation of 240. For the ACT, the mean score is 21 and the standard deviation is 6. Totally different scale. So if Bobby scored a 1740 and Kathy scored a 30 on the ACT, who actually did better? Well, if you just look at them at blanket scores, you'd say, well, wow, that's a lot bigger than 30, but is it really better? We need to look at the Z-scores. That's how we can compare them, putting them on the same scale. We're standardizing them. So to find Bobby's Z-score, we take his score minus the mean divided by the standard deviation. Anybody already get that one? So exactly one standard deviation above the average. Kathy, on the other hand, Kathy's Z-score, 1.5. Whose score is actually better? Kathy's score is better. Kathy's score is relatively better compared to other people taking that same test. So it's using Z-scores. Whoops, you can see that. Z-scores are a way to compare things by putting them in the same perspective. That's it. Yay.